Hi again. The next topic in engineering mathematics is probability and statistics. So first let's see about probability. Under this, random experiment. What is random experiment? The output of an experiment, the output of an experiment cannot be predicted, but it is one among the several possibilities. Okay, the output cannot be predicted, but it is one among the several possibilities, but it is one of the possibilities. Okay, so output cannot be predicted, but it is one of the possibilities, means that is random experiment. For example, tossing a coin, rolling a die, drawing a card from pack of 25. You can see here. So coin, tossing a coin, or rolling the die, or drawing a card from a pack of 52. Okay, so these things or comes under the random experiment, because there is a possibilities. It has some possibilities, but the outcome we cannot predict, right? So these experiments are called random experiments. Next, sample space. Sample space means the collection of all outcomes. What are all the outcomes from any experiments? Okay, so the collection of all outcomes of an experiments is called sample space. So sample space is a space where it contains all the outcomes. That's it. So simply remember all outcomes. All outcomes will be here. Sample experiment. Okay. And next one, this one is event. So the outcome of random experiment is called event. So the outcome will be the event here. Okay, so the experiment, random experiment which has some outcomes, that is event. Okay, next, where event is the subset of sample space. Yes, because sample space contains all outcomes, right? All outcomes. So this is what event is, nothing but an outcome. Event is nothing but an outcome of an experiment. So this will be the subset here. Okay, subset of sample space. Next, the chance or probability. The chance or probability of an event is P of E. So we're going to say like P of E, right? Probability of event, okay, which is equal to favorable case by total number of case. It's a favorable case and total number of case. Like if they have given some conditions like two heads or more than two heads, okay, these are all for coins. Okay, tossing a coins means, so these two conditions are the favorable case. So we need to find how many a probability which has how many events which has two heads or more than two heads. So this is the favorable case. By total number of case, total number of case means if the coins is tossed for three things, means how many total events. Okay, so the favorable case by total number of cases, and always the probability has the limit 0 to 1. It does not have any negativity, and it does not have any more than one numbers. So the last limit is 1 and the first limit is 0. That's it, 0 to 1. So it may contain 1 by 2, 1 by 4, like that, but it does not contain greater than 1. Okay, so we can easily say P of S, that is a sample space. It's a whole, right? So P of S will be equal to 1, because as the whole the last limit will be the value, so 1. If P of E which is equal to I means there is no such event, because I will come as complex term, right? So if it has I means there is no such event. If it is has 0 means impossible event. If the P of E comes 0 means it is impossible event. Okay. And next is permutations and combinations. So first one is factorial. We know that 4 factorial is what? 3 into 2 into, sorry, like 4 into, okay, this 4 will come here. So 4 into 3 into 2 into 1. So start from 4 and end from 1. That's a factorial here. So I can write this as n factorial, which is equal to n into n minus 1 into n minus 2 into up to 3 to 1, right? So this is the format for n factorial. If it is 0 factorial means don't hesitate, don't think about anything. 0 means 1. 0 factorial is what? 1. Why it is 1? Always it should end with 1, right? So just end with 1. That's it. So 0 factorial, which is equal to 1. Okay. Next, permutations. The different arrangements of a given number of things by taking some or all at a time. Okay, so different arrangements are there of a given number of things. So there is number of things, it has different arrangements by taking some or all at a time. Okay, if for example they are saying 3 boys, they are arranged differently ordered. Okay, so they have some different orders, so of number of given number of things. So 3 is the number of thing. By taking some or all at a time, I can take 3 boys all at a time or 2 boys as some at a time, right? So this is the meaning. So that is called permutations. So permutations means we can take some or all at a time in a different arrangements. Okay. For example, they are saying A, B, C letters. Yes, A, B, C or the letters. Permutations taken 2 at a time means I can take A, B or B, C or C, A. Yes, so likewise we need to finish up to this A, B or B, A, B, C or C, B, A, C or C, A. So it has 6 possibilities, right? Yes. So permutations taken 2 at a time. If I take A, B means it has 2 possibilities. So 2 means what? A, B, B, C. So we need to combine the 2 letters here. Permutations taken all at a time means what? We need to consider all 3 letters. So A, B, C. So like A, B, C, then the C will come here, center, A, C, B, and I'm just replacing it. So likewise you have to replace all the things. Just bring A here, A, B, C, C, B, next B, C, A, C, next C. So you can bring this order like this, A, B, B, C, C. Okay, so just replace the another 2 variables. You will get the same permutations, like 6 possibilities. So this is called permutations. So we can take 2, like we can take some or all at a time. Okay. Next, the number of permutations. How can we find the number of permutations of n thing? The things may be up to n. Okay. So number of permutations of n things taken or at a time. So they have given the time as or. Like it is not at all some and not at all or. All. So they are taking as or. So it may contain some or all. Okay. So number of permutations of n things taken or at a time is given by NPR. Okay, NPR. We will write like NPR. Okay, which is equal to n into n minus 1 into n minus 2 into up to n minus r plus 1. So this is the expansion. It will be like n minus 1, n minus 2 and up to n minus r plus 1. And here you can see this is the formula for number of permutation. So npr, which is equal to n factorial by n minus r factorial. Okay, this is a formula. So n factorial, n minus r factorial. You can see here, this is n factorial and n minus r factorial, right? So it's easy. N factorial by n minus r factorial. Okay. So for example, if they have given 6p2, okay, 6p2. So n is what? 6 times, sorry, 6 things and 2 at a time. Okay, so 6 things 2 at a time means we can write this what? 6 minus 2 is 4. So after that you have to write 6 into 5 into 4 into 3 into 2 into 1. Like 6 factorial means start from 6 and end from 1. But here you can see here, this alone is a 4 factorial. So this 4 will get cancelled. So only 2 numbers will be there. 6 5s are 30. But in an easy way, you can write it as 6p2 means just start from 6, because always start from 6. Okay, so start from 6, only 2 numbers, 6 into 5, that's it. If 7p3 means only 3 numbers, start with 7, 7 6 5. Okay, so this is the thing here. So you can easily find the number of permutations like this. Okay, yes, and number of all permutations of n things taken all at a time. So all the permutations of n things taken all at the time, which is nothing but n factorial. Only n factorial will be there. Okay, because all at a time we are taking all the values, all the n values, right? So taken all at the time means it will become like n factorial, the number of permutations. Okay, okay, if there are n subjects of which p1 will be like one kind and p2 will be like n kind, right? So if there is a n subjects, so first one p1 will be like one kind, okay, p2 will be like another kind, likewise so on, pr will be like rth kind, right? So it's like a subdivisions. Okay, so n subjects will contain p1 p2 p3 up to pr. So p1 will be like one kind because these are all different arrangements, right? So it will be like one kind, this is another kind, and pr will be rth kind. So I can say p1 p2 p3 because n subdivisions are these, so I can add up together to form the n, right? So p1 p2 p3 up to pr, which is equal to n. So number of permutations of these n subjects, okay, we need to find the number of permutation of this n subjects means we can easily write the total by the subdivision factorials. Okay, so n factorial, p1 factorial, p2 factorial. Like if they have 6 6 4 4 3 3 means we have to write the whole thing in the top. If they have say n which is equal to 10 or something, so the whole is what? 10 factorial by, here you can see here 1 2 2 1 2 3 4 5 6. So I can write 2 factorial, these 2's are one kind, 2 factorial 2 times, and this one is one kind, 2 factorial, this one is one kind, 2 factorial. So we can easily write like this. Okay, next comes combinations. Each of different groups or different selections which can be formed by taking some or all. So same, but each of different groups or different selections. Okay, so different groups, it may be different groups or different selections can be formed by taking some or all. So this is the outcome, like it is formed by how? By taking some or all. Okay, Yes. So by taking sum or all of a number of objects. So here permutation is different arrangements of a given number of things. Different arrangements we have to take some or all. But here different groups or different selection. It is not differently arranged, where it is different groups and different selections which can be formed by taking some or all of a object of number of objects. Okay. For example, selecting 2 out of 3 girls. So let me say A, B, C or the girls means the possibilities will be A, B, B, C, C, A. Here there is no different arrangements because A, B and B, C, sorry, B, A, these two things are equal. So there is no different arrangements. So arrangements will be same. Okay, this is the only difference. Okay, so selecting 2 out of 3 girls means we have to write like A, B, B, C and C. That's it. Number of combinations of n things taken R at a time. Same here. N, C, R. Okay, we have to put C here instead of P. It will become combinations. So n, C, R will be equal to n factorial by R factorial into n minus R factorial. You can see here n, n minus R and again a single R. So n factorial by n minus R factorial into R factorial. Okay, this is the formula here. Here the only difference we are adding R factorial as an extra, right? So we can easily write NCR into R factorial, which is equal to NPR, right? Yes, the only difference is R factorial. Okay, so this term alone will become P, right? This term will alone become NPR. So we can easily say NCR into R factorial, which is equal to NPR. For example, to find the combinations 11C4, which is equal to, we need to start from 11 and in the denominator we need to start from 4. So just start from 11 and give 4 numbers, and just start from 4 and give 4 numbers. Okay, or else just remember like this. If they have asked 12 C 6, okay, so just start from 6 in the bottom. 6 into 5 into 4 into 3 into 2 into 1, right? So 1 2 3 4 5 6. So just start like this, like 12, start from 12, 12 11 10 9 and then 9 8 and 7. You can see here 6 numbers. So like this you can easily write. So start with 4 in the bottom and end with 1. Then how many numbers are there? 4 numbers. So just start with 11 and give up to this numbers. Okay, so likewise these are all. And if they have given 16C 13 means, so it's a larger number, right? 13 means you don't need to worry, just subtract these two things, n minus r, right? Subtract it and then you can find the remaining values. You can see here, if you subtract this means it will be 3, right? 3 will be the answer. So just start with 3 here. Okay, this is the difference. And they have given some notes here. NCN will be equal to 1, means R equal to N. So we are taking N combinations. Okay, so it will be 1. If it is 0, we didn't take anything, means it is also 1. So NCN is also 1, NC naught is also 1. So these are some properties. And next thing, as we know, NCR, we can write this as NC n minus R, like here. NCR will be written as NC n minus R. Okay, so these like this. Okay, this is a property. And next one, the number of shake hands out of 10 friends if each shake hand with each other. So you can see here is an example. The number of shaking hands out of 10 friends. Okay, 10 friends or shake their hands to each other. Okay, so what is the combination? We know that 10 friends, if you take any two persons means they will shake A to B and B to A, right? So it will be two possibilities for two persons, just like that, like just write that only. Okay, so 10C2. So you have to write like this. And here number of emails out of 10 friends if each giving email to each other, like the same. A will give to B and B will give to A, right? So A will give to B and B will give to A. So each other. It's also two possibilities for two persons. So I'm just writing 10P2. So this is what? This is permutation. This is combination. Okay, so difference will be like this. Combinations means it's the two persons will shake the hand, but it is same. Okay, but we have to write in different way in the permutations because different arrangements, right? Next one, selection of or things out of n things. So we need to select or things in n things. Okay, then the selection will be, the answer will be number of selections in which one particular thing is already there and number of selection in which one particular thing is not there. If you are selecting all things means selection will be there, like a particular thing will be there and it will not be there. So it's already there, and it's not there. There is only two possibilities, right? It will be there or it will not be there. So these are two possibilities. Okay, so n c or, we will write this like it's a formula. NC or will be equal to, first take this one n minus 1 into, first take n minus 1 and then again plus into n minus 1. Just listen here, NCR will be equal to, I am just writing here n minus 1. Just subtract this n minus 1 here and here. So plus into n minus 1. Okay, after that just make this C as same in the last term. CR. Here CR minus 1. Okay, it's dead easy. Just take this n and put minus 1 in here and here. So n minus 1, just leave a gap, plus n minus 1. And here what it is CR. Just put this CR in the last term. Okay, just put this CR in the last term. In the middle, CR minus 1. So just subtract minus 1 here. So here you can see here NCR will be equal to n minus 1 into CR minus 1 and plus n minus 1 into CR. That's the difference here. So just take this n and minus 1 and CR means the last term will be CR and the middle CR minus 1. So if they have asked 6C3 means you can directly write like 6 is here. So I need to minus 1 here. So 5 will come. CC, just put CC here. And what is it is C3. So just put C3 here and minus 1 means C2. So you can see here 8C5. So I need to write 8 minus 1 is 7. So I'm just writing 7 plus 7. Okay. And C5. So just write the C5 in the last term. C5 and then minus 1 is what? C4. So it will be the answer. Yes, it's dead easy. Okay. Next we see some circular arrangements. Circular arrangements with what? In the circular we are arranging. Here we don't have the starting point or end point. So the number of ways to arrange n things in a circular order is given by n minus 1 factorial. Just n minus 1 factorial, that's it. So number of ways to arrange n things in a circular order is n minus 1 factorial. Here example, they have given some example here. Number of ways to arrange ABC. ABC is what? 3 letters. So I can easily say number of arrangements, number of ways will be n minus 1 factorial, right? So I can say 3 minus 1 is what? 2 factorial. This is the answer. So ABC in a circular order is 2 ways. So we can arrange these 3 things in 2 ways. Like you can see here, if I fix A here, ABC or ABC, right? ABC or ABC, like anti-clockwise. So clockwise and anti-clockwise. So there is only 2 possibilities, right? For 3 variables, A, B, C, there is only 2 possibilities, A, B, C, A, B, C, right? Because in case of circle, there is no end and start, right? So this is the reason for n minus 1 factorial, okay? So one place is fixed and so the remaining will be arranged, right? And just fix the A and the remaining part will be arranged. So we need to minus 1. That's the meaning for this n minus 1, okay? So we need to give n minus 1 because one place is arranged. So the remaining n minus 1 are arranged in n minus 1 ways, okay? Next one, elementary event. So we just saw what is event. Event is nothing but the outcome. So the another name of event is elementary event. It is just an outcome, right? Outcome of random experiments. So the another name of event is elementary event. That's it, okay? And sample space. We have seen that all possible outcomes in a space is called sample space, okay? So for example, tossing a coin, rolling a die. Tossing a coin means a coin, right? A coin will have head and tail, right? The another side is tail. So head and tail will be there in a coin, okay? So just a coin will have 2 faces, right? So head and tail. So I'm just writing tossing a coin, S will be equal to H and T. S is what? As a whole, as all possibilities. So H, T. These 2 things are the possibilities. Here you can see here a single H and single T is nothing but the elementary event. Like an event, the outcome of a random experiments. So this is nothing but an outcome of random experiments, okay? If I say rolling a die means dice always has 6 faces, right? It's like a cube. It's like a cube. So dice has 6 faces, okay? So dice has a 6 faces. So like a cube, right? So it has 6 faces. So these are the possibilities, all possible outcomes, okay? Next, if S represents the event means it is a sure event. If this S, this sample space represents any event, a particular event means if this S represents a particular event, H means it is this event is called sure event. It should be there. So sure event, okay? Impossible event. If there is no outcome, it is impossible event, okay? This impossible event will be like pi, okay? We will denote it like pi, and we will denote this sample space as yes here, okay? So impossible event means if there is no outcome of an experiment, okay? Equally like the event means all the elementary events of ES have the same chance of occurring. Like if there are 2 events or there A and B means A will occur and B will also occur, but they too have the same chance of occurring. So A and B will have the same chance of occurring, means it will be equally likely event. Equally likely event. Mutually exclusive events means two events does not occur together. It does not have the chance to occur together, right? It has a chance to occur together means equally likely event. Mutually exclusive means it does not have a chance to occur to, like the two events does not occur together. So it is called mutually exclusive events. For example, if I throw two dice means what? One die has six faces and another die has six faces. So total 12 faces, right? So S will be equal to 1 to 12. I'm just telling a first event which has only the sum of numbers less than or equal to 4. So 4 and less than the numbers will be, what is the sum? So they are asking the sum of numbers less than or equal to 4. So I just need to start from 4, 3, 2, right? I'm not considering this one. So just 4, 3, 2. Here they have asked another event, sum of numbers which is greater than 9. Means what? We should not include 9, which is greater than 9. 10, 11, 12. Here you can see here any number is similar. No. There is no possibility of numbers occur together, means it is mutually exclusive. Mutually exclusive events. So we can directly say like E1 and E2. Okay, E1 and E2 will be equal to, this symbol is AND. So even this is AND, okay. So E1 and E2 will be pi, impossible events. So there is no outcome for these two things, right? Mutually exclusive, sorry, this is mutually exclusive. This is mutually exclusive events and this one is mutually exhaustive events. Exhaustive events. Exhaustive, okay. Mutually exhaustive events means E1. This is union, like this one is OR function. Means it is a union. You have to take both the things. So U1, E1, E2, E3. For example, just take these two things here. E1, E2. So there is no similar numbers. So we just writing E1 and E2 will be impossible events. If I say E1 U even 2, like E1 or E2, E1 or E2, this symbol is for union. Means I have to write all the numbers. E1 has 2, 3, 4 and E2 has 10, 11, 12, right? So I have to include all the numbers. So like E1, E2, if you have m number of events means just E1 or E2 or E3 up to or EM means the full will be included, right? All the events are included means it is nothing but S as a whole. So this is nothing but the exhaustive events. Exhaustive means we will include this symbol or, okay. Combination of events means just a combinations, as I told you, E1 or E2. So this one is OR and this one is NOT. So like this. So first one is what? E1 union E2. E1 or E2. So we need to include E1 or E2 or both occurs. So we need to include E1 and E2 or both. Okay. So this is the thing. E1 and E2 means E1 or E2. E1 and E2. Right. So this is in terms of words. This is in terms of symbols. Okay. Don't need to confuse it. This one is OR. E1 or E2. E1 or E2 will be occur, right? E1 not E2 means both occur but which has a similar things. So similar things will be occur. Okay, E1 combination or complementary. Okay, E1 par C means E1 complementary, like E1 bar means the set should not contain E1. The event of yes, okay, the set of events, right? Some set is there means it should not contain E. So we can directly say E1 bar or E1 complement, like E1 should not be there. So we can write like this, or else we can write 1 minus E, E1 set. So we can write like this also. 1 minus E1 set is what? It will come as a set, but it does not contain E1. Okay. Okay. The next thing, E1 minus E2. Event E1 but not E2, right? E1 minus E2 means the event E1 will come but not E2. And here A and A bar. A and A bar means what? The element. So A will have some element here, and 1 minus of A. So you can see here I can write this like A is an element and 1 minus of A, because as I said, a set, an event, a set of events should not contain A bar. This is the meaning here. So a set of events should not contain A bar, right? So I can write this like 1 minus A. So it should not contain A bar. But here in these two things, is there any possibility of similar numbers? No, because this is A, this is 1 minus A. So A is already minused here. So there is no possibility. So we can easily write impossible event pi. Here A and A bar will be the mutually exclusive events, right? Yes, it is mutually exclusive. Probability of an event, let's say A is an event means, so probability of an event P of A will be equal to P, right? Probability, number of events, elementary events favorable to A, like probability means what? Favorable cases by total cases, right? So number of events which is favorable to A by total number of equally likely elements. Equally likely elements means all the elements. We will consider all the elements. Okay. You can see here all the elements of S is equally likely element. Okay. So we will consider all the elements. So that is what? Total elements. So favorable by total cases. And here the same probability of event will have also the limit 0 to 1. And P of pi means what? 0. Because impossible event probability will be 0. Here probability of a sample space will be 1. Okay. Probability of sample means 1. Impossible means 0. Law of addition. There are some laws for the probability of events. Okay. So what is that? P of A or B. So this is what? R, right? So P of A or B means there is some possibility. So there is some formula like P of A plus P of B minus P of A and B, right? It's like a formula like A square plus B square minus 2AB. Likewise, P of A or B means we can write this as P of A plus P of B minus P of A or A and B. So here it is and. Okay. So you can see here P of A union, A or B or C. I'm just adding 3 events. Means you need to add 3 events first. So P of A, P of B, P of C. Minus just combine 2 things. P of A and B, P of B and C, P of C and A. So just combine 2 events and then at last as a whole event. A, B, C. In and. Okay, P of A and B and C. That's it. But in combining 2 things means you have to put minus symbol here. You can see here negative symbol. Okay, this is a formula for law of addition. If A, B are mutually exclusive, means what? A, B should contain all. So, A, B is the whole event. If A, B are mutually exclusive, then A not B will be equal to pi. Pi means what? Impossible. So, A, B should not occur together, like it is mutually. So, A, B should not occur together. That is what? Mutually exclusive. It should not have any chance to occur together, right? So, that is mutually exclusive. We have seen that mutually exclusive means it should not, they both do not have any chance to occur together. Like we can say like A and B will be equal to pi. There is no possibility of occurring together. So this is mutually exclusive. Okay, this is mutually exclusive. And P not A, we can say this P not A as P bar, A bar. Like as I said, we can easily say 1 minus A. Okay, so A bar will be equal to 1 minus of A set, right? So likewise, probability of A bar will be 1 minus P of A. So as the whole, this is the highest limit. That's why we are taking A here. Sorry, 1 here. Okay, highest limit. So S does not contain A. Here S does not contain A. Okay, because A bar. So the event should exclude A. That is A bar. Tossing a coin. So here first one we gonna see tossing. Okay, coin tossing. Okay, so tossing coins. If I toss one coin, mean as I said, a coin has two faces, right? So two ways, head or tail. If I toss two coins, means two coins, like here is already a two ways, two faces, and again two faces. So it will be 4. So I can write this as 2 part 2, right? 2 part 2 ways. Like the combination will be head head, tails tails, head tail, tail head. And n coins means 2 per n ways. Okay? Yes. So an n coin will have 2 per n ways. If I say 5 coins or tossings, means I can say 2 per 5 will be the ways times. Okay? Yes. Next one. Question. Okay. If 3 coins tossed, so they are saying 3 coins are tossed. So we can easily say 2 part 3 is the ways. Okay. So they are asking same face and more heads than tails. So they are saying same face and more heads than tails. We can easily say the probability will be like, the probability will be like what? Head, 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 tail, head, tail, head, 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 tail. So likewise, you need to arrange this. You can see here, first thing is head, head, head. Next T here in the middle, and in the first and in the last. So this one is completed. After that, just put head, H in the middle and in the last and in this last, both corners. So head is finished. At last T, T, T. So you can easily say 2 part 3 ways, right? So 3 coins means 2 part 3, which is nothing but 8. So 8 ways are there. Yes? Okay. So first thing they are asking same phases. Same phases means H, 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 T, T, T. These are the same phases. So I can easily write 2 by 2 part 3. So you can easily say same phases in coins always be 2 only. Whatever may be the coins. If they have said 10 coins, means the probability of same phase will be 2 only. Okay, always it's 2. Because coins has only 2 faces. Okay. More heads than tails. More head than tails. Like the head should be more, like here you can see here only heads, so more heads, here more heads, here more heads, then compared to T it has more heads, right? So what's the probability, like the number is 3, you can say here more heads means I can say this one 3 heads and 2 heads. I can't say 1 head because T is greater than, okay, T is more here. So only I can take these 4 possibilities, these 4 things. So I can say only thing 3 hedges and 2 hedges, right? So the head should be 3 or head should be 2. So I can write this thing as n into C3, 3 heads, and n into C2. So they are asking more heads, means this is a favorable cases. So I can write this as C3, C2, okay, 3 and 2, 3 heads and 2 heads, more than tail, okay. So I can write like this, and you can see here n is nothing but a number of coins, so 3 coins. So I can easily write 3C3, 3C2. This 3 is what? For head, 3 head. This one 2 head, 3 times, like 3 coins, okay. So we have found these 2 things. So just add up together by total. So add the favorable cases by total, we will get the more heads than tail. So these are the 2 favorable cases, just add up together and by the total. Total is what? 2 power 3. Total ways. By simply you can write like this without this. You don't need to put all these things because it is for 3 coins. If they have asked for 5 coins means it's difficult to write those things, right? Because we need to save the time. So for that purpose we just write head, tail. So head will be 0, head will be 1, head will be 2, head will be 3. These are the possibilities because 3 coins. So tail will be 0, tail will be 1, tail will be 2, 3. These are the possibilities. Just write 2 to 3, sorry 0 to 3 and in the reverse 0 to 3. And you can easily say in these 2 numbers in which are the numbers which have more heads than tails. You can see here 2 is greater than 1, 3 is greater than 0. So I can easily say there is 2 numbers. So just write C2, C3. And how many coins? 3 coins. 3 into C2, 3 into C3. That's the thing. So these are the favorable cases. So we can write this favorable cases add up together by total number of cases. Okay. For example, they have given 4 coins or tossed. Like before we have seen 3, right? Here 4 coins. So the ways will be 2 power 4. Same question, same faces and more heads. You can see here same faces is nothing but 2. Always it's 2. So 2 by 2 power 4. First one is finished. More heads than tail. More heads than tail. Just write H and T here. So start with 0, 1, 2, 3, 4. End with 4. And start with 4, 3, 2, 1 and end with 0. Okay. You can see here more heads than tail. This is equal. So these 2 things are more, right? More than this thing. So we can easily say 4 coins, right? 4 coins, 3 C3 plus 4 coins C2. Sorry, C4. So 3 and 4. By the total cases is what? 2 power 4. So this will be the answer. Okay. Sorry, here 4, 4. Okay. 4, 3C, 4, 3, 4. Right. The same. Okay. So you can easily write like this. So this is the answer. Okay. You can see here these 2 are the possible cases. So I can write 4 coins, 3 C3, 4 coins C4. Okay. Just add those 2 favorable cases. By total you will get the answer. Okay. And the next sum, a coin is tossed until it shows the same face in consecutive throws. In 2 consecutive throws. A coin is tossed until it shows same face. So the coin is tossed again and again until it should face same, it should have the same face. Okay, in two consecutive throws. Only the two throws. What is the probability of success by tossing a coin not more than 4 times? So the coin is tossing 1, 2, 3, 4. So it should be tossed up to 4, not more than 4, and only two throws. And it should have same face in the possibilities. So what are the possibilities? So let's take coin tossed for second time. We can't take first time because first time is tails. Her head and tail will be there. There is no possibility of same faces, right? Same face. So just omit this one. First time. And coin tossed for second time. Only two throws will be there. So second time means head, tail, tail. So you can see here both has two faces. So same faces. And again coin tossed for third time. So already head is there. So if it is tossed means you can just write like in the reverse order, like there are two heads or that, just add T here, and there are two tails or that, just add head here. So you can see T H T H H, again H T T. So these are the two possibilities for same faces in two consecutive throws. Okay, again coin tossed for fourth time means just the same. Here T is there, so two heads are that, one tail. Again add head here and tail here. So you can see here first for the second time the both will have T T H H, and I need to add T in this H. Okay, the third time will be T H H and H T T. So I just add H to the T and T to the H. Again fourth time means I need to add H to the T. H T H H and T H T T. Okay. Again if they have asked for fifth time means, so I can easily say T H T H H. So you need to add T here and H here. If I add H here means H T H T T. So likewise it will goes on. So this is a same face in two consecutive throws. So the throws will be two only. These two things only. But it should have the same face. So I'm just changing the H and T here. That's it. Accordingly in an order. Okay. So the probability is what? Here there is only two things, right? So second time is only 2. 2 by 2 power 2, because the case is what? Coin is tossed for 2 times. So I am just writing 2 power 2. Coin is tossed for 3 times. 2 power 3. 4 times. 2 power 4. Right? And here you can see here 2 events are there. So 2. 2 favorable cases. 2 favorable cases. 2 favorable cases. Because they have given only the 2 throws. So just 2 to 2. The answer will be 7 by 8. And here n is what? Number of times tossed. So this is the n. N means number of times tossed. So how many number of times it is tossed? So 2 per n. 2 times, 3 times, 4 times. So likewise we can easily get that. If they have asked not more than 3 means just omit this. So these two things add up together will get the answer. This is for not more than 3 times. You can see here not more than 3 times means just omit this. These two things alone will give the answer. Okay. Okay. And let's see another sum. A, B simultaneously toss. If A, B is simultaneously toss a coin. So A, B or two persons tossing a coin simultaneously till one of them gets head. So any one of them will get head. So up to that they are tossing the coin simultaneously, like A will toss a coin and B will toss a coin. A will toss a coin, B will toss a coin. Likewise they are tossing the coins simultaneously until the one of them gets head. So they are tossing the coins 1, 2, 3, 4 like this. So I can easily say if A is tossing the coin and B is tossing the coin, if B win means A toss a coin, so it may be tail. and B again toss the coins mean it will get head. So B will win. Like one of them will get head means the winner is B, right? So if A starts, so they said A starting the game. If A starts the game, then what is the probability for B to win, A to win? How can we say B? So what are the possibilities like B will win and A will win? Okay, so A should start. So these three things are main thing. Okay, so how can we say B will win means B should have the head. If A is win means A should have the head, right? So start from A. What are the possibilities? Not only one thing, because they are tossing the coin simultaneously. So we need to write like this. So I'm just taking. You can see here B wins means tail H, like first A is starting, A lost. So I'm just writing here as A lost, okay, and B won. So first time, first B should win, right? So A is tossing and B got win. So A got tail. As I told, A had T and B had H means B won the game. So likewise, A lost and B won. Okay, tail head. Head comes means 1. Okay, so A lost and B won. Again, second possibility is what? Again, 2 will be added. So add 2 T's here. Means the lost. A lost, B lost, A lost, again B won. So the second time B won means there is just add 2 T's. 2 T's which is nothing but A lost the game and B again lost the game and A again lost the game and then B won. You can say this is for the first case, and as a whole is for the second case, because A tossed, B tossed, A tossed and again B won. Okay, and the third case, so likewise just add 2 T's. So in this thing add 2 T here, again in this thing add 2 T here, these two things. So just add 2 things in this function because AB, right? So AB are simultaneously tossing the coins. So in this case you can say tail is 1, head is 1. Okay, ways which is nothing but 2 per 1 only. So both are tossing the coins only 1. So I'm just saying 1 by 2 into 1 by 2. Tail is 1, right? So 1 by 2. 2 is nothing but 1 coin. So 2 per 1 is 2. Ways. So 1 by 2 into 1 by 2 plus likewise it will go on. So you can easily say this as 1 by 4. If you multiply this, it will be like 1 by 4 plus 1 by 6. So you can see here there are 2 coins are tossed. So we can easily say 2 per 2. That is 1 by 4. Here there are 2 coins like 2. Again they are tossing the same things, but we are adding 2 T's in extra. So I am just adding 2 per 2, okay, into 2 per 2. I am just adding 2 T extra. So 2 per 2. So it will be 2 per 16. Again 2 per 2 into 2 per 2. This is the last term. Into 2 per 2. I am just adding 2 T extra. So 2 per 8. Sorry, 2 per 6. So it goes on like 2, 4, 6, right? 2, 4, 6. So this is the ways. This is the answer. Okay. So it's like a form. There is a formula here like A plus AR square plus AR cube up to this. So we can simplify this formula as this term as A by 1 minus R. So you just need to find A and R. Then you can easily write the answer for this whole. So these are the, this thing is what? These are the thing we have found here. Okay, it's like A plus AR. So first term is what? 1 by 4. This is nothing but A. So we have found the A. A which is equal to 1 by 4. We need to find R, right? Second term is what? AR. So I can easily say AR which is equal to 1 by 16. Which is nothing but 1 by 4 into 4, right? So 1 4 is A and another 4 will be R. So R will be equal to 1 by 4, right? So 1 by 4 divided by 1 minus 1 by 4 will be the answer for this. So you don't need to confuse all the terms. Just put two terms alone because we only need two terms. Okay, for your understanding I'm just told three terms here. Okay, so this is the thing. So A will have, as I said, A is 1 by 4 and R is 1 by 4, right? So the answer will be, this is a term here. So this one is A and this one is AR. So A is 1 by 4 by 1 minus 1 by 4. Answer will be 1 by 3. Okay, and see here, if A wins means they have given start with A, right? So it's easy because A in the first thing A had head, so A1. Again 2 T's, add 2 T's here and A1. Again add 2 T's here. So just add 2 T's. So you can see here this is the possibility of 1 by 2 plus 1 by 2. So I am just adding 2 T's here. So 2 into 2 power 2. Okay, so 8. So it will be 2 to the 4. So 4 2s are 8. So 8. Again 2 into 2 power 2 into 2 power 2. I am just adding 2t again. Okay, so this will be 32. Likewise it will be go on. So just it will be go on. Just take the two terms alone. So A is what? This is A. And here this is AR. You can see here I can easily write this 8 as what? 8, which is nothing but 4 2s are 8. So 1 by 2 is 1 by 8. 1 by 8. 1 by 4 into 2. So you can see here 1 by 2 is A. Then 1 by 4 is R. So you can easily write A by 1 minus R. The answer will be 2 by 3. So the important thing here is this one. You need to understand this. Okay. So TH. First B1. So first A lost and then B1. Again A lost, B lost, A lost, again B1. Again the same thing. So for your remember, just think, add 2t extra in every term. You will get the answer. Okay. Next one. Rolling a dice. Here comes the dice. Dice always has 6 faces. So 6 ways. So a single die has 6 ways. A double die, 2 dice will be 6 power 2. As you can see in coins, 2 power 2, 2 power 3, right? So same here, but here is the 6 because 6 power 2. So it has 12 faces like 1 1. The combinations will be 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. Again 2 1, 2 2, 2 3, 2 4. Likewise up to 6 6. Okay, the combination will be like this. So 6 square, 36 terms will be here. Okay, 6 square. Likewise n dices means it will be 6 power n ways. Okay, so in 2 dice A, B, or this is for a note. In a 2 dice, if A and B is said to be like 2 dice, A and B, 2 sides, or said to be equal means this is that what is the possibilities means 6 ways. Because in 2 dice we can say like 2 dice, right? 2 dice. We can say like 1 1 will be the possibilities for both, or say 2 2, 3 3, 4 4, 5 5, and then 6 6. So how many ways? 6 ways. So you can easily say A which is equal to 6 ways, right? A which is equal to B means 6 ways. And again one is greater than another. Okay, so we can easily say that if one thing is greater than another means, or A is greater than B or B is greater than A, it has 12 faces. So just remember this thing. Okay. Okay, so let's go to the sum. 2 dice are rolled together. Okay, 2 dice, so 6 power 2 ways. What is the probability of getting same face and sum as 10? Same face means, as I told you, same face means 6 will be the answer, because 1 1, 2 2, 3 3, 6. Always 6. Like as I said, in coins, whatever may be the coins, 10 coins, 11 coins, but same face means only 2, because coins has 2 faces. Likewise here, same face is only 6, because the coins has 6. Okay, so same face means 6 by 6 square. sum as 10. So here in this 36, sum which gives 10, here it is 4, here it is 3, here it is 7. Likewise, the 10 will come. 10 have to come. If you add these two numbers, you can easily say the first number will be 5 by 5 and just add here and minus 1 here. So 6, 4 and 4, 6. These are the only possibilities, right? So 3 possibilities. So 3 by 6 square. The base is what? 6 square. So favorable by total case. Total case is 6 square. Favorable is just 3 things. Here 6. Okay. And they have asked next thing. Sum more than 10. So sum which has more than 10. More than 10 means we can't say 5, 5, right? So just start with 5, 6. Will be 11. And again 6, 5. So this is also 11. Then 6, 6, 12. So there is only 3 cases. So we can write 3 by 6 square. And then first number more than second number or second number more than first number, whatever may be the thing. As I said, A is greater than B or B is greater than A means there is 15 ways, 15 favorable cases. So 15 by 6 square. If it is for 3 dice rolled, so they are saying for 3 dice rolled. So it will be like 1, 1, 1, 2, 2, 2. Likewise it will go on. Okay. So 6 part 3. Right. So 6 cube will be the total ways. Okay. Same face ways always 6. Okay. Sum more than 16. So they had given 16 here. How can I get 16? 16 means it should be greater than 16. So greater than 16. We can't say less 16 equal to 16 or less than 16. So they have given sum as more than 16. So we can easily say like if I have to get 16, right? So 5 plus 6. So these are the possibilities. 5 plus 5 is 10 plus 6 is 16. But I can't take this one because it is 16. I need more than 16. So I can say 6, 6, 5. You can see here this is 12. 12 plus 5 is more than 16, right? So this is omitted because I can't take this one. So this one is omitted. So I have to take 6, 6, 5. So what are the possibilities for this? Like 6, 6, 5 and 5 will come in center, 6, 5, 6 and 5 will come in this corner, 5, 6, 6. So these 3 things are the possibilities for more than 16. Again 6, 6, 6 is also a possibility because it is also more than 16. So there are 4 things. So 4 by 6 cube. So if they have asked some numbers like this means just bring some numbers to add this thing like in the same order. Then you will get 3 orders and then at last the last order. So we will get 4 by 6 part 3 and 4 dice rolled. If they have asked 4 dice rolled, so the ways will be 6 part 4 ways, right? And here same face means always 6. So this is the thing. So next thing they have asked 20. The sum will be 20. The sum will be 20. But we know that 20 means 4 dice. 1, 2, 3, 4 dice or die. 20 means I can start with 5, 5, 5, 5, right? Then this is the first ways. And then I can say like just add 1, 1 here. Okay. Just add 1 here. Like 5, 5 will be the same and just add 1 here and minus 1 here. This is also a possibility, right? So likewise you can see here. So probability formula is what? N factorial by n minus 1 factorial. This is the formula, right? So n factorial by n minus 1 factorial. Okay. So we will see that. So what are the possibilities here? So 5, 5, 5. Start with 5, 5, 5. Just add 1 here, minus 1 here. So 5, 5, 6, 4. And just add 1, 1 here. 6, 6, 5, 3. These are the possibilities. So we need to give some possibilities to get the answers. Okay. So these are the possibilities. So in this thing I will tell you how can write these things in the formulas. Okay. So 5, 5, 5. Just add these 2 things. But you can say like 5, 5, 4, 6 is also a possibility. Yes, this is also a possibility. But I'm just writing as a whole as 1. So these things are all comes under here. Okay. Okay. So 5, 5, 5 is the possibilities. Next one, 5, 5, just add 1 and minus 1. And add here and like add 1, 1 here. So take again minus 1, minus 1. So add in these two things, in these two numbers. So 6, 6, 5, 3. Okay. So I'm just taking 1 here, 1 here. So it will become 5, 3. I'm just adding 2, 5 plus 1, 5 plus 1. So 6, 6. 6, 6, 5, 3. Again, take a number 1 and add here 1. So the order will be like plus 1, minus 1. So you will get the same. Okay. And here, just minus 1, minus 1, plus 1, plus 1. Right. So the order will be the same. Again, here is what? Plus 1 here and minus 1 here. So you will get like this order, right? And the last one is minus 2. I'm just adding this minus 2 here, here plus 2. Okay. So they have given some orders like this. We need to find how many ways in this thing. So we can say 5, 5, 5 means there is only one way. And like if I take this thing, okay, so 6, 6, 6, 2 means I can easily write 6, 6, 2, 6, right? This 2 will come here and again this 2 will come here and again this 2 will come here. So what are the ways here? 4 ways, 1, 2, 3, 4. Likewise, we will rearrange the numbers. So first we need to find the term and then we can easily rearrange the numbers and we will get the ways here. So how can I find this? This is what is somewhat simple, so I can easily find, but here there are 12 ways, so we can't find. So I'm just telling the easy way to find it. Okay, 1, 2, 3, 4, 5, 5, 5. So 4 number, or normally the dice is 4 dice, right? So 4 factorial, n is what? 4. So just write 4 factorial in all numerators. And then n minus r means r is the different numbers. We are taking the different arrangements, right? Here, is there any different arrangements? No. So the arrangement will be 0. Here you can see there are 2 different numbers. So I am just writing 2 here. So 4 minus 2, n minus r, right? So n minus r. Here again 2. So I can easily say n minus r. So 2 factorial. 12 ways, 12 ways. Here you can see here the arrangements is different, but it has 2 and 2. As I told you, 6644 means you can write this thing as 2 factorial and again 2 factorial. You can write like different, you can write like separately. So 2 and 2. Okay, so 6 and 4 4. So 2 factorial, 2 factorial. Again you can see here at the last thing only one number is different. So 4 minus 1. So this r is nothing but different numbers. How many different arrangements, different numbers are there. So by doing so we can easily find the ways. So this term alone has 6 ways. So this term alone has 12 ways. So we are just making the terms first and then we are rearranging the numbers. Okay, we will get the ways here. So totally how many ways? 35 ways are there. So we have found 35 ways. So we can easily write like 35 by 6 power 4. Ways by 6 power 4. Yes, this is the whole ways. This is the favorable cases, favorable ways. Okay. Next sum. A, B simultaneously roll dice. So A, B are simultaneously rolling the dice till one of them gets number 4. So whom get number 4 will be the winner. Okay. So this is the winning point. If A starts, so likewise A starts here. What is the probability for B to win and A to win? Just you need to find only the 2 terms. You don't need to worry about the third term. Okay. First thing is what? B to win. So I can easily say like 4 is the number. 4 is the number. So this is 4. In the even 4 will be the number. If they have got 4 means that person will be the winner. Right? Winner. Okay. But in words like this is what? A single phase in 6 phase, right? This is a single phase. If I said tail means this is a single phase in coin. Coin has 2 phase. So I can write like this. So 4 is nothing but single phase in 6 phase. Other than 4 is what? 1, 2, 3, 4 will not come. 6, 5 and 6, right? So other than 4 there are 5 things. So I can write 5 things in 6 phases. 5 phases in 6 phases. So the number will be like 5 by 6 will be the loss and 1 by 6 will be the winner, right? So I can easily say 5 by 6. So A start. A is the first person to start. Okay, so A start. A lost and then B won. So I'm just saying 5 by 6 because A lost. A will have the number in this bracket. But here you can see here winner is 4. So 1 by 6. So if a person has 1 by 6 means that is a winner. So B is winner. So first A start, A lost and then B won. Again A lost. Again A B won, B lost. Again A lost because just add 2 things. Like in the previous case we are adding 2 T's rice. Likewise we need to add 5 by 6 here. This is failure case. Okay. So 5 by 6 A lost, B lost, A lost. Again B won. So the last term B1, right? So we need to add extra 2 terms here. So just 2 terms are enough. Okay, 2 numbers. We just need to add extra 2 numbers. Okay, 2 terms are enough. So what is A value? This whole thing is the A value. And AR means you can easily say 5 by 36 is A value by 1 minus AR. We need to find, they have given the term as AR, right? So we need to find R. Here you can see here 5 by 6 into 1 by 6 is nothing but A. So remaining part will be the R. What is the remaining part? 25 by 36, right? So I am just writing 1 minus 25 by 36. Okay. So this is A. So I am just taking A outside and you can see here 25 by 36 will be the R. So just write those things and you will get the answer as 5 by 11. Next thing, A to win means first A won, so 1 by 6 plus A lost, B lost and then B won, A won, right? So we need to add these 2 numbers as extra like TT, okay? So I'm just adding. So you can easily say this one is A and this one is A means this one is R, right? Yes. So 1 by 6 minus 1 minus 25 by 36. R is same for both cases. Okay. So by doing so, we will get the answer as 6 by 11. Okay. So this is the thing. And next sum, there are 2 based. So okay, there are 2 based dice of which one die shows even number twice as frequently as odd number. Like they have given based dice means which is nothing but the dice. Okay. So they have given 2 dice. Okay, here they have given some conditions here. So we can't write 6 for 2 ways because they have given some conditions. So we need to find the ways according to these conditions. The first thing they have said, first die shows even number twice. So in every even number there occurs twice of that number as frequently as odd number. We know that a dice have 1, 2, 3, 4, 5, 6. So 6 faces. This is for a die, a single dice. Okay, a die. Okay. In this thing, there are 6 faces. They are saying even numbers is twice. Let us take 2 as a common. Okay. So in even numbers, so 2 as a common here. So in case of even numbers, there will be twice into 2 as frequently as odd numbers. You can see as odd even. So it is in a frequent order, like next order. Okay, so order odd even. In place of even you have to write into 2, like it is twice, right? So this is the meaning for that, and this is for the first dice condition. Second dice shows 5 thrice as frequently as any other number. So second dice shows fifth position as thrice. So I can easily say 1, 2, 3, 4, 5, 6, right? So in the fifth position, it is thrice into 3. Then compared to other numbers, if I said L everywhere means, we can easily say other numbers in the fifth position there will be thrice the number. This is the condition for second case. So they have given two conditions here. If these dice are rolled together, what is the probability of getting some 10 and more than 10? Okay, so we can't, just like that, we can't say 6 power 2 is the base, right, as I told you. So we need to find the conditions here. You can see here dice 1, dice 2. As I told you, dice 1, wait, in dice 1 they have said a condition like even number should have twice as frequently as odd number. So this is odd. I'm just taking here, I just took 2, right? So I'm just taking k here, a constant value. Okay, k. You can see here even number will have twice. So into 2 into 2 into 2. K 2k, k 2k, k 2k. Is this is clear? Yes. So this is the first case. And the second case, in the fifth position there will be thrice, right? So the dice 2 shows 5 thrice equally as frequently as any other number. So all the numbers will be same, but in the fifth position it will be thrice. So 3L. So just add all these things. It will be 9k and 8k. What is the total? Which is nothing but 1. So I'm just equating this thing to 1. So I can easily get the value k is 1 by 9 and L is 1 by 8. So these are the two cases. Okay, these are the two cases. So let's say here sum as 10. So we need to take the sum which is 10, right? So I'm just taking the first dice will have 5, 5. So 10 means what? 5, 5. So plus 1 and minus 1, 6, 4 and 4, 6. These three things are the possibilities as we already seen that. Okay, but here a main thing is what? In normal sum we will write like 3 by 6 square because 2 dice. So 6 power 2. But here we can't write like that, because here they have given some conditions, right? So for this thing, just we need to consider a single numbers here. 5, 5, 6, 4, 4, 6, right? So just concentrate here. 5, 5. Okay. So I need to take this 5, 5. Just see here. Where is the condition applies for 5, 5? Only in the second dice, right? This is the constant values. So 5 has a condition only in the second dice. So I can write the first dice as it is, 1 by 9. Second dice will have 3 here, 3 by 8, because 3 is the condition here. So in the fifth number there is a condition 3. So I am just writing 3 by 8. Okay, is this clear? Okay, the next number 6, 4. You can see here 6 and 4. So 6 and 4 has the condition only in the first dice. So I have to write here is 2. 2 is common. Okay, but the main thing is the both numbers should have the condition. So this is very, very important. In this thing, the both numbers should have the condition. Then only you can apply this thing. Okay, so 5 is also having the condition, 5 is also having the condition. So this 5 number has the condition at second device. So second dice, so I can easily write 1 by 9. This is the first dice. 1 by 9 into first dice into 3 times of the second dice, because here the condition is 3. Again here 6, 4. You can see here 6 and 4. It has 2. The condition is 2 here twice, right? In the first dice only. So I can write 2 times of the first into second one. 2 times of the first and into second one. Again 4, 6 the same. 4, 6 means the same twice. So two conditions are that, like twice, right? So just multiply 2 into the first one and then into the second one. You will get the answer. So in case of condition, you have to consider a single numbers. So it is must the both numbers should have the condition. And some more than 10. So I can write like more than 10 means 11 and 12, right? So 5, 6, 6, 5 and then 6, 6. These three are the possibilities. So I have to write the condition according to this. So you can see here 5 and 6. Both has a condition, but the one thing is what? This is from one device, this is from one dice and this one is from another dice, right? So 5 is from second dice. So I have to write thrice the second dice. So 3 times second dice. And 6 is what? In the first dice. So twice. So 2 times the first dice. So I can write 2 by 9 into 3 by 8. 3 times the second dice and 2 times the first dice. So likewise here, the same here. 6, 5 means 2 times the first dice, 3 times the second dice. Again 6, 6. 6, 6 means only the first dice. So I need to write 2 times the first dice into second one. So this is the answer. Okay. Then pack of cards. Okay, pack of cards. What is the total cards? 52 cards. As we know, there are 52 cards in a pack. In this 52, just divide into half, 26, 26. So 26 cards are red and 26 cards are black. Okay. So 26 cards are red and 26 cards are black. And then just divide by 2. 13, 13, 13, 13. Here 13 cards are spade. Spade will be like this symbol. And clubs will be like this symbol. Diamonds will be like this symbol. Hearts means heart. Okay. So they have 4 different symbols here. Spades, clubs, diamonds and hearts. In these 3 things. So red has only diamond and hearts. So black has only spades and clubs. So spades, clubs means it will be comes under the black card. So diamond and heart will come under the red card. Again, in each thing there are 4 honors and 9 numbers. In each spade, clubs, diamond, hearts, there is a common thing. So all the things will have honors and numbers. In this honors means A, J, K, Queen and King. So Jack, Queen and King. A, J, Q, K. In this thing, these 3 things has the face cards. These things are said to be the face cards. And this one is not in the face card. A is not in the face card. The 3 things J, Q, K, these 3 honors are in the face cards. Okay. Then numbers means 2 to 10. So 9 numbers. So 2 to 10. We will consider this A as 1. Okay. So 1 is here. So 2 to 10. Okay. Then 2 cards are drawn. So the problem is 2 cards are drawn at random from a pack of cards. So they are drawing 2 cards as a random, okay, from the pack of cards. So total cards are what? 52 in a pack of cards. Both must belong to the same suit and both must belong to the different suit. Like same suit means what? Same, like same suit means in same in same order, like in similarities. They both should be drawn from the same suit or both from different suit. These are the 2 possibilities, right? So if I said red card and black card means the same from red card or one red or one black. So these are the possibilities. So or same from black or one red or one black card. So these are the possibilities. So they have given the 2 possibilities here. So we will find that. So 2 cards are drawn, right? 2 cards are drawn. Total cards are what? 52. So 52. Okay, how many cards are drawn? 2 cards. This is nothing but the favorable, right? Favorable case R, right? So 2 cards I am drawing, 2, 2. So denominator is clear, right? In numerator, we know that 4 honors, like I have to say card 1 and card 2, right? So I am just taking the card 1 as from 4, these 4 honors, and then card 2, okay, and the 2 cards, like the first card, okay, the first card in 4 honors, and the remaining part 13 spade, or like as we said spade, heart, then diamonds, and then clubs, right? So these are the 13 cards. So it may be taken from, so the card 1 will take from, the possibility is from honors, and then from 13 cards. So this is the thing here. So 4C1, 13C2. So this one is clear, and this is for same suit, because if they have same suit means we can easily set 13 as a common. Okay, so the second card may be from this 13, and the first card from honors. But here, if it is different suit means we need to change the thing, right? The second card is from 4, is from honors. So card 1, card 2. So this thing is from 13. So I need to write like 13 and 13, card 1 and card 2, card 1, 1. Okay, so 13, and card 2 is for 4 honors, 4 honors. So okay, is it clear? So totally 52 cards, and the favorable case we are taking 2 out of 52. So I am just taking in 4 honors the card 1, and 13 clever, like the 13 divisions, right? So 13 from 2 cards, card 2. Okay, likewise here the 4 honors I am just taking the card 2, and in the 13 honors this is different shoot, so we can't say in the same manner. So I just need to say like red and black means, so 13 card. So this is red and this is, I am just writing as it is two things here, 2 terms. So 13C1, 13C1, right? If it is 3 cards means just write 3 here. In terms of 2, just write 3 here. You can see here, so we are taking 52 cards. So we are total is 52 cards. We are taking 3 cards, right? So 52C3. And here you can see 4C1. So in honors I am just taking the 1 card and another 3 cards. So just replace 3 in place of 2. That will be the answer. So 13 will be in 3 cards. Okay. So card 2, card 3 is for 13. If it is different shoot means we need to write 3C1. So the same here. Instead of 3, just replace 4. It is for 4 cards. Okay. This is the thing. Then a card is drawn at random from a pack. So a card is drawn at random from a pack of cards. What is the probability that it is king or red, king or queen? So they have given some conditions. So a card, only a single card is drawn from a pack of cards. Okay. Normally they have given 5 conditions. Okay. First thing is what? King. King means there is only 4 kings will be available. Like as I said, A, J, Q, K, these are the 4 honors. So these 4 honors will be in 4 things like spade, heart, like in the 13 cards, right? In the 13 cards, these 4 honors will be there. So spade, heart, clubs and diamonds. So in this 13 things, there will be 4 cards, right? So I can easily write the king will be here, 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 here. So 4 kings will be there, right? 1, 2, 3, 4. So 4 kings will be there. I am just taking the king alone. So I can easily write 4 by 52. This is the favorable case and this is the total case, right? Okay. Next condition is king or red. So I can easily write the formula, right? Possibility of king or red. What is the formula here? As we have seen this formula, A or B means P of A, probability of A plus probability of B minus probability of A and B. So just replace A, B as K, R. Probability of K, which is nothing but 4 kings. Probability of red. Red means there are two, means in the 52 cards we need to half divided it. So 26, 26, this one is red and this one is black, right? So 26 cards are from red. 26 by 52 minus, I'm just gonna take this thing, okay? K, K and R. Okay, K and R means in red car, so these two things must have a common thing, right? So in red car, how many kings are there? You can see here I said 4 things, right? So 4 divisions like this: spade, heart. So in this thing, heart is red card and the diamond is red card. The another things will be the black card. So in this 2 red cards, here will be 1 king, here will be 1 king. So there are 2 kings in red cards, right? So how many kings are in the red? Only 2. So 2 by 52. So by doing this calculation, you will get 28 by 52. So this is what? King or red. Next thing, king or queen. The same formula. How many kings are there? 4 kings. Likewise, how many queens are there? So if I take queen means there will be 4 queens in 4 divisions. So I can easily say 4 by 52. And king and queen. Is there any common thing is here? So we can't take any common. So it is 0. This is mutually exclusive, right? So it does not have a chance to occur together, K and Q. Okay, so this one is 0. So I can easily write this as 0 and the answer will be 8 by 52. And then next thing, king or face chord. This is a face chord. Okay, face chord means what? 3 chords are face. J, queen and then K, right? These 3 chords are face chords. So I just wrote the formula here. P of K means 4 kings. Face chord means there are 4 divisions. As I said you, there are 4 divisions and 3 chords are here. J, Q, K, right? 4 divisions are there. So 4 division, 4 into these 3 chords. So 4 into 3, which is nothing but 12 by 52 minus. In face chord, how many kings will be there? So totally there are 12 chords. Like in 4 division, how many kings are there in the face chords? The same, 1, 2, 3, 4, 4 kings. So 4 by 52. We will get the answer as 16 by 52. And the last one they have asked probability of king and queen. As you know, there is no possibility to occur together, so it is 0. Next one, a card is drawn from a pack of 52. Find the probability that neither diamond nor face. So diamond is not there and face is not there. It is like a complement. Okay, so we need to write this like a complement. Okay. So diamond, I am just writing like diamond should not come. So the set should not have diamond. So I can easily write this as D bar or D complement. Likewise F bar or F complement. This is the meaning for that. For this thing, I can easily write 1 minus D will be the answer for this, right? So neither diamond nor face. So P of, they have given nor here, or sorry, they have given yes, or. Okay, so this is what? Nor. It's like and. Okay, so I need to write like P of D complement and F complement. So these two things should not come. So for this purpose, I am just writing 1 minus or. Okay, I am just writing this as 1 minus or. So if D complement and F complement means this is equal to D union F. Okay, so this is what the thing, 1 minus P of D union F. Okay, so it will be like this thing, I'm just replacing it as 1 minus this thing. Like I'm just replacing the and to or. So 1 minus the thing. Okay. So as I said, D bar is and, D is what? Union or. So I'm just replacing this thing 1 minus the union form, which is equal to, I'm just applying the formulas here. You can see here D is for diamond. So there are 13 diamonds in 52. Okay. F is for phase chords. So phase chords means 4 into 3, right? 4 divisions and 3 phase chords. So 12 by 52. Minus D and F. Diamond and F. So how many phase chords are there in diamond? 3 phase chords, right? Diamond has 1 divisions. So 1 into 3. So 3 phase chords. By doing so, we will get the answer. And they have asked another thing. Neither 10 nor a king comes. So neither 10 nor a king comes. Okay. Neither 10 and nor a king comes means we can write it like 10 complement and k complement, right? Probability of 10 complement and k complement. I'm just writing this as 1 minus union. So p of 10 union k. Okay. Okay. And the next thing, 1 minus p of 10 plus p of k minus this one. This is the formula. And you can see here how many 10 will be there in 52. Like as I said, numbers will be 2 to 9, right? 2 to 10, 2 to 10. So there are 9 numbers. 9 numbers in 4 divisions. So 1, 2, 3, 4. So 4 tens will be there. So 4 by 52. King, it is 4 by 52. Minus king and 10. There is no such relation here. So it will be 0. So this is the answer here. And the next topic is leap year concept, but I'm just gonna put this leap year concept as a single video so you can easily understand more about this leap year concept. Just do watch it. I am going to tell a clear idea about the leap year concept. So like leap year, non-leap year, and how many possibilities are there. So it is very easy. Just watch it. It will be the next video. And thank you so much for watching this video. So soon we will finish this engineering mathematics. Bye.